You guys having a good time so far? It's been productive? Still not a lot of energy in this room. Good luck with that panel, because I don't know if you're going to get a lot of energy out of this audience. So we're going to do a quick introduction. Each person up here on the panel is going to introduce themselves. My name is Kelly Richardson. I'm Vice President of Strategic Planning and Marketing for Rinaldi Consultants. And I'm here working with this fine group of people to talk to you about dynamic airspace sharing. So with this, I'm going to start from left to right and let them introduce themselves, and we're going to jump right in. Is everybody ready? Come on, give me a little bit of something. Okay, there we go. All right, Jenny, go ahead and introduce yourself.
All right, good morning, everybody, and thank you for coming up to our panel this morning. My name is Jenny Boyle. I spent 31 years in the Federal Aviation Administration. I started as an air traffic controller at Washington Center, held various jobs. I quickly learned that traffic management, flow management was my passion. I spent half of my career in traffic flow management. I was the air traffic manager of the command center. I was fortunate enough to rise to the level of Vice President of Systems Operations, which oversaw security division and the command center, along with a lot of other parts of our directorate or service unit, as well as liaisoning with the military as well. So thank you for having me.
Thank you, Jenny. Matt, please introduce yourself.
Thanks, Kelly. Good morning, ladies and gentlemen. I'm retired U.S. Navy Vice Admiral Matt Winter. I'm a current Senior Executive Advisor and Board Director on several different companies across different industry verticals, from emerging technologies, unmanned systems, and national security. 4 years ago, I retired from our U.S. Navy after a 35-year career. Starting out flying the A6 intruder off our big deck aircraft carriers, so a naval aviator. Transitioned into our U.S. Department of Defense acquisition enterprise, where I led the men and women of industry, academia, and government, where we would design, develop, and deliver the platforms, the sensors, and the munitions for our U.S. military and also our global allies. I finished up that career. The final two was the Chief Technology Officer, the Chief of Naval Research for the United States Navy, and then the F-35, which you may be familiar with, the F-35 Program Executive Officer, running that trillion-dollar global enterprise. I've been a consumer of airspace my entire career, a user in multiple different roles, which has given me some unique perspectives to be able to shape and formulate the strategy plans and policies for airspace governance. I look forward to your questions. Thanks.
Thank you, Matt. Craig, please introduce yourself.
Bonjour, Madame et Monsieur, comment allez-vous?
Did you do a good job?
I want you to know that I have been on Duolingo for the last 3 months, and if I didn't do well, I'll stay on it, otherwise I'll cancel my subscription. Welcome everybody, good to be here. My name's Craig Drew. I spent 40 years in the airline business. I started off with a small company back at the time named SkyWest Airlines. They're now the largest regional carrier in the United States. And then I went to Southwest Airlines back in 1990. Started off as a pilot, had the opportunity as a chief pilot for a few years, and then I was vice president of flight operations, and then I retired 4 years ago as a senior vice president of air operations. And we too use a lot of airspace, and look forward to using it some more. I just flew in a very, very slow airplane that you did.
I don't know, that A6 is not very fast. A little faster than yours, though.
But he did say the F-35.
He did say that one. I'm thinking the A6. I used to work on A6s when I was in the Navy. All right, and then for our list, we got a lot of new people in here. You guys ready? Is everybody some energy? I'm glad you guys are sitting up here close to me, because now I'm going to pick on you all. So our last person on the panel, I'll let Justin introduce himself as the President and CEO of Airspace Data. So go right ahead.
Good morning. Thank you, Kelly. Appreciate it. Thank you all for coming. Thank you to my fellow panelists for joining. I am the founder and CEO of Airspace Data. We're working to automate how militaries, ANSPs, and industry connect on military airspace availability so that you can increase throughput through that space, mitigate congestion in various NASAs around the world. I've worked in aviation, one capacity and another, for about 25 years, including helping set up the Transportation Security Administration for the Secretary of Transportation after 9/11, very glad to be out of the security business. ATC is a lot more fun. But what I would say is that there was a lot of stakeholder work required in that role, and that is a huge part of what we're trying to do at Airspace Data. And trying to keep all these stakeholders happy is not easy, but I think that's where prior efforts have fallen short, is not making sure that DoD's priorities are met at the same time the FAA's and the airlines' priorities are met as well. So that's really central to what we're doing. We'll talk about it more during the course of the panel.
All right, thank you, Justin. So we're going to kind of walk through this panel a little bit to discuss what the current state is, how we can make it a little bit easier, more efficient, fuel efficient, reduce CO2, reduce workload, and then come up with a solution at the end to talk about it. So with that, I kind of want to bring up Jenny first. So Airspace Data is talking about at-scale sharing of airspace between military operations and ANSPs. But my question for you is, currently, working to use military airspace, how difficult or how much work goes into being able to use that to allow the airliners to fly through it and open it up, like transitions between controller, military, and so forth?
And thanks for the question. So, as I was saying, efficiency has been my passion, throughout my career. And
Basically, I'm hearing it's probably not very efficient.
yeah, so, and trying nuances in order to get those efficiencies. Presently, it is antiquated how we communicate with each other. It's Excel spreadsheets, scheduling a whole week. You get the whole week blocks of time, and in order to communicate, it's a lot of different phone calls, having the airspaces go inactive or hold to activation, and then coordinating that through either the controllers on the floor to the supervisors to outside facilities, adjacent facilities, as well as the command center. So any way that we can streamline that, connect the connectivity that we're missing, and in real time is what we're really looking for. And then there's other instances as weather starts training across the country and how you can activate and deactivate that airspace.
I've got to tell you, it's in my mind to hear that we're working airspace with Excel spreadsheets. Does that not just seem like 1990, like 20, 30 years ago, right? So with that same thing, on the military side, how much of a hindrance is it for you all to work with the FAA to do kind of the same thing? And I'm really kind of curious. You all use spreadsheets as well?
We do, but they're pivot tables. It's the next level up. It's not that bad. Everybody know what a pivot table is? No, okay. No accountants out there. So first, the need for our military use airspace is unquestioned, and the FAA and the Department of Defense, at least in the United States, agree on that. The efficient use, because we're effective, of being able to have three-dimensional swath of airspace is what we're talking about. The Department of Defense schedules that airspace every day, and multiple times a day, and pushes that schedule forward. The issue is that the schedule is something to deviate from, and we deviate from that every day in operations. And over my career, the complexity of those deviations and the scope of the scheduling has become much more complex. However, our process to do that has sort of stayed in the decades-old manual engagement, make sure I got eyes on the schedule, send that in, and then the day of execution, I'm picking up phones, I'm calling people, I'm etching things out on paper. Not that that's not effective, but it certainly is woefully inefficient. And so there's opportunities here to automate or at least communicate faster and more real time with the FAA specifically to be able to tell them when airspace is no longer being used, or it will be used, but there's little sections of time when it won't be used. We need that real dynamic, real-time sharing. Thanks.
So Craig, coming from an airline perspective, because I'm not gonna lie, this sounds inefficient from an outside perspective. But coming from an airline perspective, trying to work with the FAA, trying to work with ATC, operations, flight ops, and so forth, and then working through the military airspace, how inefficient is it for you all to be able to use the current system?
Well, let me back up and just kind of give a little history lesson here. When I got hired at Southwest in 1990, I flew the 737-200, 122 passengers, and it burned on average about 6,000 pounds an hour. Today, you've got the 737 MAX-8 with 175 seats, and it burns about 4,500 pounds an hour. And so you think, well, that works out to be about 49 to 50 pounds per hour per seat in the 200, and in the MAX about 25. So you think, well, that's great for saving all kinds of fuel. And that is true, that's a true statement. The challenge is back in 1990 when I got hired, fuel was about 65 to 75 cents per gallon US, in the US. Now, if you take inflation, that works out to be about $1.80 per gallon today. What do you think we're paying for fuel today, jet fuel? Anybody know, other than the Southwest people who do know?
Anybody want to raise their hand and say it's over $5 a gallon?
No,
Who wants
it's
to bet
not.
that?
Maybe
$3 a gallon?
Maybe it is in Europe, but at one airline in the United States, it's about $3.10 a gallon right now. But it has been much higher than that. So you can still see saving fuel is critical to an airline. Burning fuel is very, very expensive. And so by being able to take these shortcuts to save fuel, but the other thing too is time. You're saving block time, and I can go into that a little later on if you like. But fuel is very, very critically important to airlines and saving it because it is next to labor, it's your number 2 cost.
And with that amount of fuel and time, CO2 emission as well.
Absolutely.
So with this, come to you, Justin, and can you talk about what the plan is with Airspace Data to develop dynamic airspace sharing to kind of make this process, because this process seems kind of antiquated, right? And you look at it and you're like, it seems like it's 1990 whenever Craig got hired at Southwest, and we're still doing it in 2023. How do we bring the airspace up to today's standards using airspace data?
So what I would say, just as for quick context, is that we've got a couple of challenges that we have to overcome. One is that airspace management, I think the words and concepts are a little different in Europe, but fundamentally similar. It's being run at a facility level. So each carrier is filing flight plans that they're building themselves. You have 22 en route centers handling higher altitude traffic across the U.S. that are tied together by the command center at one level, but are managing traffic on their own. And then you have 24 major training ranges for the military, 4 smaller ranges that have some common tools. The Air Force uses a tool for scheduling across all their ranges. The Navy has a tool, so does the Army. But fundamentally, each range owns its own airspace. So you have to understand at the beginning that you've got all of those bases to touch, which conservatively is about 50 if you take the FAA facilities, the big ranges, and the big airlines. The second thing then is how does data move? And as we've sort of all alluded to here, data flows are constricted. DoD will produce a schedule for use of a training range. That schedule is out of date almost as soon as it's printed. It's not an airline schedule. It's subject to what's happening with how the exercises are run, and fighters might be down on the ground before the training, the scheduled window is closed. And the way that all those real-time updates get shared is by telephone, which isn't 1990, it's sort of like 1940. And we're trying to unlock all of it. So this has to do with automating how data flows, again, between military, the FAA, and industry. And here, it would be Eurocontrol and ANSPs in the middle, individual national militaries, and then the many dozen carriers in operating. And we'll get into a little more detail later, but that's the challenge, is automating how data moves among all these stakeholders.
Can you bring up, because you're talking about the military airspace within the United States, and I think this is an interesting number, because I already know the answer to this, but what percent of the airspace is it that we're trying to unlock?
25%. It's a huge percentage of the NAS. And when you look at the 4 key corridors that we're really focused on, it's much higher than 25%. So off the Atlantic coast, by the way, this impacts inbound and outbound transatlantic and trans-Pacific traffic, obviously. So off the Atlantic coast, over the Gulf of Mexico, White Sands Missile Range in New Mexico, but that blocks traffic between all points east, but really Texas, Arizona, and California. And then traffic in and around Nellis, which impacts Las Vegas, which in turn impacts LA. So in those 4 quarters, it's more than 25%. If you spread across the whole mass, it's 25%. It's a huge number. 30,000 commercial flight plans miles a day. It's a big impact.
So, and kind of bringing this back, I'm going to kind of pivot on this. So Craig and Jenny, this one's kind of for you all, for an airliner. Right now, you can't file off the ground to go through this airspace. So you're flying around this 25, whatever that chunk of the 25% is, you're ending up filing to fly around it. But in the ATC facility, if it's open, you might be able to shortcut you through this. And then you have to coordinate that. Not having a plan or a process to do it, you still right now have to go through that same avenue of filing it this way, and then maybe we get to do this. So it's not a definite thing. You all talked a little bit about that, certainly with Craig from a user perspective, and then I'm curious from an operation perspective, controller.
So one of the challenges you have with that, for example, if you're flying from Las Vegas to Oakland, you have to have enough fuel on board to fly all around that military airspace. So when you get the shortcut, if you get the shortcut at the last minute, you've got all this extra fuel on board. There's a cost to carry, that's expensive. But then when you get to Oakland, you might get there 15 minutes early, you might not have a gate. You have to sit there for 15 minutes. Or, because you had all this extra fuel on board, you're too heavy to land, you've got to burn it off anyway. And so it would be wonderful if you could fly right through that military airspace, knowing beforehand on your flight plan. That is the key, and that's what they're trying to do.
So, Brian, you bring up a very good point. How many of you, because this happens to me all the time, take a flight, you get to your airport early, and then you sit there and wait for a gate? Does that happen to anybody in this audience? Let me see a show of hands. Is that like an often thing? Wouldn't it be nice to get there early, and then you're actually leaving the airport early? So, talk about this. We can plan this off the ground, and you can file off the ground. Then they have a better opportunity to plan for a gate to be available whenever you get to the airport. Just want to make sure.
Absolutely, absolutely.
How great would that be? All right, so I'm feeling the love here with this. So on the same token, as an operation controller standpoint, how does this create workload for you all to do the way that we're doing it now?
I actually want to give you 2 different examples, one from the controller's perspective and then one from the traffic flow management perspective.
Love to hear it.
Okay. So for controller perspective, if they're filing off the ground, less transmissions for the controllers. The ATO top 5 safety initiatives, it's been several years running that airbag readback errors are in the top 5 for the safety initiatives. So it's less airbag readback that the pilots are taxed with listening to where they have to go. If it's a different fix this day compared to this day, that they didn't get the shortcut. And then maybe potential point outs because you got a shortcut in a different area and it's cutting through somebody else's airspace, which is more workload on another controller, etc. So that, if they can file off the ground, it's more direct and it's less transmissions. It's a plus for everybody, for pilots and controllers, reference workload. Then when it comes to the command center and traffic flow management, when there's some sort of anomaly in the national airspace system that we work, that you sit there and you're trying to decide on ground delay programs, airspace flow programs, how you're going to manage this traffic. And a lot of times there's these big blocks of airspace, as like I said, the weather's training through, and now more aircraft are funneling through a smaller amount of airspace. If you could know real time when that airspace is going inactive, that will help the fan out that traffic in order to let it flow more efficiently through the airspace. So that's a bonus for both of us, all 3 of us really.
With Matt, because I know you have something to add, and I have a question for you. Go ahead.
So it sort of paints the picture that the military use airspace is this cancerous barrier to efficient airline operations, right? It's important to know that the military use airspace and the mission that it provides is critical to all of our nations, right? And for the men and women that control that airspace, they are not trying to make it hard for the airlines. In fact, they believe when they pick up the phone and tell the FAA that the airspace is cold, they're doing their job, and they've done it as fast as they possibly can, and they hang up, right? And they say, we've opened up the airspace. When that information gets to the FAA, there's a period of time to be able to turn that around into an effective operational benefit. So from the military use airspace, it's important that we continue to advocate for the appropriate amount of military use airspace. If you talk, from my perspective, we don't have enough in the United States. You're like, what do you mean by that?
That was going to be my question.
Right? Because 40 years ago, when we were starting out aviation careers, right, we were flying a lot less complicated, single mission type of operations. We are now in the system of systems, advanced communication, netted capabilities of surface ships and space systems, the aircraft, ground systems, electromagnetic spectrums. And so we need huge swaths of airspace to be able to do true training and readiness. And before you say we can do it in the virtual world, at least in the Department of Defense, they have really invested in doing the LVC, live virtual instructor, to take some of that demand off of the actual flying in the airspace. So what we see now, though, in my eyes, is that we do need to be more automated or real-time collaborative partners with the FAA so our airlines can operate more efficiently.
Go ahead.
I just wanted to add one thing. I do believe that the military is a good tenant of the airspace, along with the airlines, and now with commercial space operations. Everybody understands that they have to co-share this airspace as quickly and efficiently as we can, because everybody has either a mission or, it's a mission also to get people to, to go see their first grandbaby. That's why I said I love connecting people with people. Very important life moments for people. But with some of the military airspace, it is some folks that are a little bit lower level in the military, and it's blocked for maybe it's scheduled for 12 hours during the day, and it maybe go inactive for 3 hours because one of the missions was going to be canceled during that time period. But sometimes to make all of those phone calls to go wherever, they're like, well, by the time I deactivate it to activate it, did it really help much? Yeah, there's some of that it's just a misunderstanding of the airspace as well. So if we can get that, thought process out, and it was required that they could hit a button to show that it's inactive, that, the airlines could flow right through there during that time period, that would be an exponential savings.
So, and you bring up a very good point about the military and how and the operation between the two. But and I kind of want to go back to your ETC background with this question. For a controller, the frontline person working this, how much work is it, or that is put in to be able to give these shortcuts, to make those phone calls? How much extra things is it that they have to do in order to do it? And is it something that, when you're sitting there in that front line, is it something that you're readily wanting to do because I don't have the work, I don't have the space in my environment right now to be able to do this, so I don't have the time to put into it?
Well, each one of our ranges or ATCAs, different military airspaces has different requirements. It depends how many sectors that they may touch, different facilities that they may touch to make not just one phone call, but they may be making 4 or 5 phone calls. If you're the control, sometimes it comes into the controller, sometimes it comes into the traffic management unit, so it's different flows of information, so it's not streamlined exactly. And as the controller, if you're sitting there at the sector and you're getting told that information that the airspace is now cold or is going hot, you have to turn around and tell your supervisor. The supervisor may put it on a status board. Then you have to tell other areas within the same building. Then they're telling the traffic management unit, and then in some cases they're turning around telling the command center. So it's lots of different communication pieces all the way around.
So to me, it sounds like humans are working like an Excel spreadsheet. Does it feel like it's that, antiquated? Like we need to move up to today. Justin.
Yeah, so I want to just draw some of that out really quickly. Back to Craig's point for a minute. I want to just emphasize that being able to file off the ground not only reduces controller workload, but it does measurably increase airline access. So we've been flying with Southwest and Delta since last June on one test route, and we've completed 2,400 flights. And Southwest and Delta's access to the airspace because they're filing off the ground has gone up by a factor of 7. United, which is not part of this test, but flies the same route, Houston to Atlanta, is staying flat. So 7x increase by virtue of flying off the ground and less work for the controllers. The other point, just to draw on what Ginny said, is that all of that manual data handling is why this doesn't scale, because you're burning daylight while you're trying to figure out the status of the airspace. And so the automation that we're going to build is expressly designed to overcome that problem. Not only is it reduced workload, but the airspace will get open faster. And then one thing, just to draw a comment that Matt made, one of the other challenges in our system, and I think it's a little smoother, my impression is, with Eurocontrol involved here, is that the request process for DoD, so we're talking about releasing airspace back to FAA, but the request process to get airspace off range in the F-35 is not uniform, largely not automated. And what ends up happening is it's quite disruptive to airline operations, which means FAA bears the brunt, because the airlines in turn complain to the FAA, which then has to go try to fight that battle with the military, and the military is looking for this airspace to complete training missions, these 5th and 6th gen fighters before airspace. And so you've got an issue there, and our sort of motto for the military is request release. It's both, not just releasing, but making sure it's easier to request airspace. That's part of how we're trying to nurture military along as a stakeholder, provide upside for them in the context of the solution we're building.
So, and with this, it's also, when you're creating routes through this military airspace, can you talk a little bit about how that dynamic between all of these entities is working to create that route, that test route that you've already worked?
And I would say it's working, I gotta catch me on the right day, some days it's working better than others, but what I would say on the routes piece, and I'll get to the larger issue, is that yes, in order to file off the ground, there has to be a route. We do not have free flight, and in a lot of cases, there are fixes that exist inside these MOAs, special activity airspace, ADCAs, whatever the case may be. But a route, airport to airport, is never filed using that fix. And so in the case of this test route from Houston to Atlanta, there's a fix that sits inside the ADCA. We worked with the controllers in all 3 centers to establish the route. They were trained. That route exists, and now Southwest and Delta are filing that route when the airspace is available, and that fix is included in the script. By the way, our technology provides real-time status to dispatch so that they know the airspace is available. The route is set up prior input into the database of routes. In terms of bringing the stakeholders along, I would just say 2 things. One, as I mentioned at the outset, you have to drive positive value for each stakeholder. So to be blunt, ATC does not care about Southwest fuel. They just don't care. And so that's not how you bring FAA along. You go to FAA and talk about mitigating congestion and reducing control of workload. For the airlines, you're talking about reduced block time and fuel expense, CO2 emissions. And for the military, reduced workload to share with FAA, but also increased access to airspace to hit their training and readiness missions. And you have to drive that every day. If there's no positive value, it's just not going to work. And we've seen that because it's been tried and failed 3 or 4 times, and I think that was a big reason why.
So, and with this, there's 2 points that you bring up that I kind of want to hit. And man, we talked about, and I'm going to come back to Greg because then we're going to build off of that. Oh yeah, he was excited. You could see the energy. He was ready to talk, but we're going to pivot first. So Matt, my question for you is, so we're talking about the F-35 and the need for more airspace to be able to fly this aircraft around. Having a solution like airspace data, how does that enable the military to be able to use more airspace? How does that working together with Jenny, the ATC side of it, allow you all to have more flexibility for that aircraft?
That's a great question. So let's put it in terms of demand by the military for airspace to sort of start with the requirement. And as we look at today and into the future, the advent of the F-35, which we call 5th gen, and then we have the follow-on 6th gen, it's not necessarily the aircraft that's big, right? The way it operates and the way it conducts its mission, and therefore the way it needs to train so that the sensors and the pilots and the ground controllers can actually get what we call reps and sets, requires their sensors to be able to look at large swaths of airspace that's not polluting. When we say that, can't have airliners flying through it, can't have windmills with Doppler shifts flipping around, all things of that nature. So looking for those large swaths of increased airspace. We operate right now in the current confines of our military use airspace, but we need larger, farther than that. Add to that the increase in our munitions, long-range weaponry, and hypersonic capabilities requires short periods of time of large volumes of airspace to do these types of things. And so those demands aren't willy-nilly and they're not expected, and there needs to be coordination. And I have seen coordination with the military and the FAA looking to see the best way to service that increase in military use airspace demand. My concern is that the schedule, like we talked about before, we put it out there and then something changes, and it's usually not the weather. It's usually the electronic tracking systems or the other infrastructure. So therefore, the use of that airspace is either delayed, or it starts and it's delayed, or it's not started at all. And though I said that it's effective to do the phone call, a solution that provides immediate visual as well as controller and decision maker input to spread information of the status and my need for that airspace immediately across all of the stakeholders is not a physics problem. Right now it's a policy and a cultural problem. And so airspace data, as I understand their solutions for this week, can bring forward that technical solution.
And you bring up something about the schedule. And I'm curious, whenever the military is out there getting ready to do an operation, going to train whatever it is that we're going to do this day. And I know there's a lot of factors that can go in to kind of change it, but how far in advance are you all planning this and setting this schedule out to prepare for that training day?
Yeah, so you really have three tiers, right? You've got day-to-day tactical squadron level, going out 1, 2, 3 ship type of training. Then you have organizational regional training. Then you have large campaign training, right, and exercises. Those very large that take things we call like Tribe Inspector and Rim Pack and things of those nature. They're scheduled a year in advance. Okay, a year in advance of this is what's going to happen, and then they work the specifics over the next 365 days. Those ones are not as tough because there's understanding of those large ones. I think the real benefit is that tactical day-to-day, when I'm going to go out and use that boat, I'm going to go out and use that boat, and I'm blocking that swath of airspace off the Los Angeles corridor, and then I don't use it. Right? So that's the real benefit that I see of potential real-time airspace status sharing capability for, at least for the military. And it sounds like the benefit for the FAA and the airlines.
And the interesting thing on the military side is you kind of think about being from the outside, let's just go out there, it looks like a good day, let's go out there and fly and use this airspace. But that doesn't just happen, and you all plan everything way out.
So gone are the days where I throw around my white scarf, jump in my open cockpit with my cigar hanging out, and I just go fly wherever I want to. Right? So there's still some misperceptions. The military is not as regulated, but it's not as open for. So absolutely, you have to have the coordination, and that coordination is okay, but it could be better. The military could be much more open versus demanding on the FAA, and the FAA could be more automated and understanding of the demand signal for the military, from my perspective.
I just wanted to add one thing before I got hired a year and a half ago. I was down in the Florida region, and just to let you know how the military is acutely aware of everything going on, and the communication is starting to get much better with some of these missions that are a year in advance. There's this one airspace in Florida where it takes up a large swath, and it's like their yearly mission. Well, also it's the same time as the Miami Boat Show. And there's a huge amounts of people that fly in for the Miami Boat Show, and now that we've got this huge swath. And so we're talking about communicating some of these airspaces and huge missions that they're doing. If they just switched in a week, would have helped the airlines, have fewer delays going into some of these airports as well. So
So, and as a passenger or as a consumer of this system, I want to Craig now. Because I want to know about that filing on the ground. How does that benefit me? How can this tool benefit me by allowing you to do that?
I want to back up first because Justin said something about block time and that should be addressed.
Let's go for it.
So it's not just saving fuel for the airlines, it's a thing called block time. For example, 1990, to fly from Dallas Love to Austin, Texas, an old 200 was 55 minutes. It now takes an hour and 5 minutes. And there's many, many reasons why. We won't go into that here. But the point being is it's taking longer and a faster airplane to fly the same distance that we did back in 1990. Block time is extremely important, and here's why. You take an airline that flies 4,000 flights per day. If you can shave off just 1 minute, 1 minute's no big deal. If you shave off 1 minute, that's 4,000 minutes. Divide that by 60, it comes up with 666.6 hours. Divide that by 11 average hours flown per day by an airplane. You've just freed up 6.5 airplanes. A new MAX is $130 million. That's not what airlines pay for. Let's assume it's 100. You're going to save $600 million in CapEx by saving 1 minute on every flight every single day. So there's much more value there than just fuel. And you know, if you save 2 minutes or 3 minutes, I mean, you know, the sky's the limit, and that's one of the things that Airspace is hoping to do.
So Craig's going to teach a math class at the end of this. But with that, but saving that minute, that benefits me as a consumer, benefits everybody out here. How does that affect us?
It affects everybody. It affects the passenger because you are going to get there earlier. It's going to affect the airline. You're going to save fuel. You're going to save block time. It's going to help the military. They're going to help us. And it's going to help the FAA because everything's automated. And you don't have to make 27 phone calls to fly through there.
So now we've kind of created this environment, and I want to bring it to you, Justin, because now here's the solution. We talk about everything that's going on, but how do we solve this problem? And how do we fix it? So can you talk about the tool?
Yes, so I think there are a couple of key principles that underlie what we're doing from a solution standpoint. The first is we're not in a position to rip and replace out existing systems. I think this is where prior efforts have failed. As you all know, and many of you are either using or selling these systems in, there's a very crowded landscape in aviation technology generally. As I said, in the US, Army, Navy, Air Force all use separate systems to schedule airspace. We know how complicated the FAA's technology portfolio is. ERAM stars and then dozens, if not hundreds, of systems underneath them. And then in an airline, you not only have a flight planning system, you have a nav database that helps you manage your routes, and then there's a larger flight planning environment, flight management environment, with a bunch of tools. There's weather tools, there's dispatch visualization tools. So we've had as a principle from the beginning that we need to plug into that ecosystem in a very customer-friendly way. We're not in a position to quote-unquote start over. It's just a fool's errand, and it's been core to what we're doing. The second thing is we've got to build highly configurable tools that really meet the needs of each user. And so the architecture for the military and the FAA is to build a web-based tool, basically the real estate that we need in a range operations center and an FAA en route center is sort of one tab on the browser. Now that's pretty simple from a user interface perspective. The computer science is happening underneath that, obviously, in terms of how data is flowing. But in your mind's eye, you should think about a web-based tool that, again, very easy for a range operator, or in our case, a traffic management unit. I think in the UK it's called an AMS. Everybody's got slightly different names, but folks that are handling en route traffic, not on scope, but one level up from the controller. So web-based tool, again, the key is to get real-time status and move it through. Now on the airline side, I think that the way we started this test with Southwest and Delta is a web-based tool for dispatchers to use. That's all fine, but they want to try to collapse the number of screens as well. And so I think over time we'll morph into a data feed, which again is what we do, or airspace data that will run via API into these existing systems. And I think for some airlines, we'll go right into a flight planning system. In other cases, it will go to the nav database and turn routes on or off depending on availability. And in other cases, it may hook up to a visualization tool like Flight Explorer, CAE, Fusion from the old IBM. There are other tools out there, and I think it'll just be transparent to the dispatcher. They just need to know the status of the airspace. But you've got to hook into existing systems, and we are going to deploy separate tools for each stakeholder group. There's no other way to do it. There is no central command authority for how airspace gets used. You might be able to pull that off in China, but it doesn't work here. DoD, militaries, ANSPs, and the industry are all separate things, and that's just how it's going to be.
So basically what you're telling me is the difference of using the Excel spreadsheet and me bringing up my Starbucks app and ordering a latte.
If you were using Excel to order coffee today, you would never get your coffee, and it probably costs 5 times as much. And so the Starbucks app is much easier. Yeah, that's right. And the thing is that another way to kind of look at this is that in a lot of military meetings, Matt said they have pivot tables, it's advanced use of Excel, but they're using Excel to schedule airspace. And the way it works is they've got airspace sectors across the top and airspace users down the side, and then each block is a time window, and there's altitude associated with it and so forth. Once that schedule's baked for Wednesday, sort of half-baked, kind of held together with duct tape, then they stop and they go to Thursday. And so what happens on day of with Wednesday is all the changes and adjustments and status changes are managed by phone. They don't even go from Excel. So going from 2024 to 1984 to 1944. It's backwards. We've got to go to like 2044. And so that's the problem, is that there's manual interference. And look, there's a safety culture. All three of these folks embody it. You're always going to keep airspace closed or keep an airplane away if there's any question on safety. And so what ends up happening is access is constricted. 2019 in the US, 4% of all flights got manual shortcuts through military airspace. When our system's in place, that number is going to be 17 or 18%. And as Professor Drew laid out with math, that's big money. And that's it. You're going to go from 4% up into the high teens. It's not going to be 80%. That's not realistic. Military's got to train. But a 4 or 5-fold increase in military airspace, and we think we'll be at 5 to 6 minutes of flight, not 2 to 3. It's big.
Right, so we only have a few minutes left. I want to start with Jenny. Having this tool in your operation, what does that mean?
Well, it depends what's going on and what's impacting the airspace at the time. So for the center airspace, I'll just talk about air traffic centers alone. Like we talked about a little bit with the controller workload, that they're busy, things are going on, weather may happen, there may be some VIP movement, something else that's occurring in their airspace. If they're filing off the ground, they're able to go through, and it's one less thing for me to have to worry about to coordinate with other entities as well with the adjacent airspace. From like a command center point of view, that helps me understand what airspace I have to work with, because like I gave an example of the weather training across, whether I'm going to do a ground plane program or an airspace flow program, or put route structure into the NAS to helping other people understand what nuances should be happening in the airspace.
So Matt, a tool like this, how much can it benefit the military to be able to have something that more seamless?
Yeah, it depends on the viewpoint of the military customer, because right now they don't see anything broken. They see inefficiencies, and they're effective. They're meeting their training and readiness goals. They're getting the use, and the things are happening. So what we really need to do is we need to be able to narrate crisply and clearly the value proposition to the military of why an automated tool suite, it benefits them. Not why it benefits the airlines or the FAA, but benefits them, right? And it's not as clear cut from a numbers and cost reduction or workload, for example. What I see though is the Department of Defense is an interagency in the United States. It's similar to across Europe. We react and change our processes based upon mandates from the National Airspace Executive Agent, which is the FAA. So a tool like this, if it was told you had to automate or reach a lower period of latency to inform airspace staff, military military used airspace, then we would have to do something more than pivot tables and phone calls, right? But right now, there's no mandate for that, and there's no requirement for that. And the air traffic or controllers are used to it, and it works. So the problem we have right now is we're going and show them something, they go, I don't have a problem, and so you don't need to fix anything. Not invented here. I'm sure we've all had those types of opportunities to help. I know from my experience and in helping sort of noodle through to the right individuals in the Department of Defense that there is benefit from this. There's incredible benefit, not only from helping the partnership here, but from reducing our carbon footprint, increasing the opportunity for training and readiness, time to train to reduce that. So we're ready, our military is ready to go, and to be able to accept and expand hypersonics, unmanned systems, systems, and larger range capabilities. There's a lot of benefit here that automated status sharing system would definitely bring to the table. And it would bring to the table to our European friends as well.
Oh, this is awesome. So Craig, I have a two-part question for you. One is, because I think you can kind of help us, how would a tool like this benefit the airline? We know about planning but being able to be ready for flight ops, do it. And at the end, how does it benefit us?
You're going to save time.
Who doesn't want to save time when you're flying somewhere? We're all tired of sitting on that little airplane. Come on.
You're going to save fuel, which means you're going to save CO2 emissions, which is important. And those, all three of those, plus you're going to save time on the airplane. So all three of those will come together to provide a very, very good product. One other thing I want to mention, I know we're almost out of time, I want to adjust this time. SAF fuel, special aviation fuel, is now 2 or 3 times more expensive than jet fuel. When that comes into play, this will even be more valuable to the airlines. I'll leave on that point.
Perfect, thank you. And then Justin, we're going to let you kind of close it out, but I do have a question for you, if you can throw it in there. This tool, when can we start seeing it?
So let me answer that, and then I'll make it a little deeper. So the airline portion of our tool is out. The airlines are using it now. We released the version 1. So we used a prototype from June to December for the initial flights. Version 1 of the proper application we released in December. Version 2 is about 2 or 3 weeks away. And then what will come after that are the API feeds we're integrating into the systems. On the DoD and FAA front, I think we'll have prototypes ready by sort of Q3 of this year, and then initial rollout of initial functionality by the end of the year. And again, you're automating not only existing processes, but how data flows. That is pretty good timing because the real expansion in terms of routes I think will happen in 2025. We'll continue to stair step up, but our view is that 17 or 18% in the U.S. system is about 5,000 commercial flight plans a day filed through special use airspace. And probably when the dust settles, it'll be in between 800 and 1,100 airport pairs. And so if you think about it, it's 800 to 1,100 strips, maybe a little bit more, probably average 1.5 or 1.4 per route, but new routes to create into these nav databases and then file off the route. The other thing I would just mention, just to take it up a level, just kind of from a CANSO perspective, is that this is one of these, the title of the panel is Solving a Decades-Old Problem. This is one of these gap issues that has kind of fallen through the cracks, despite everybody's best efforts to try to address it over the last 25 years. I think there are probably a long list of issues like that. Some of you in the room may be working on some of them. Again, our kind of foundational principles here, you got to leverage existing technology wherever possible, and you have to provide value for all stakeholders wherever possible. I think though the lack of focus on those two things has hurt prior efforts as it relates especially to airspace in the U.S. But I think the same principles apply to other ATC and NAS issues that we're all addressing all over the world, but obviously particularly in the U.S. and Europe. So I just want to offer that from sort of an experience perspective, that's what's enabled us to get as far as we've gotten, and I think it's going to be critical to achieving this. So I'd sort of say that.
So, and because we have to close this up, and I'm sorry we didn't have time for questions, but I could probably talk for another 20 minutes. One real quick question for you, Justin. How scalable is this tool for Europe and the rest of the world?
So I think Europe is definitely the next place for us to go. I don't know how many more regions are really achievable beyond Europe, but I think given the number of ANSPs, the number of ministries of defense, the number of airlines, the obvious very challenging congestion problems, staffing shortages on the controller front, but also a big focus on ESG, reducing CO2, that Europe is really the next place. That's one of the reasons we're here. It's why I was in Madrid in September, and that it's really becomes also a focus for us in 2025.
Perfect. Well, thank you, panelists. Did they do a good job? Let's give them a round of applause. Thank you, everybody. I appreciate it. And I hope that everybody enjoys the rest of your time here at the conference. If you have any questions, these guys are going to be hanging out, so ask them something hard. Especially Craig. He'll teach you math.